All right, matrix multiplication. Before we move on to 2.2, I just want to give you guys a quick intro on how to multiply two matrices together. All right, so the first thing we need to check is that the dimension must match, meaning, let's say A is an n by n matrix and B is an n by p matrix, and the result is going to be an n by p, given that the number of columns of A is the same as the number of rows of B. Right? If these two number matches, then the resulting matrix, let's call that AB, is going to have the dimension m by p. Yeah. So let's look at one simple example. Let's say I have a 2 by 2 matrix, 1, 1, negative 1, 1, multiplied by 2 by 3. So let's say 0, negative 2, 2, 1, 0, 3. All right. So let's go ahead and check the dimension first. This is 2 by 2, and this is 2 by 3. All right, so this number, the columns of the first matches the rows of the second, meaning we can keep going with our matrix multiplication. Okay, now in 2.1, we actually look at definition on how you can multiply two matrices together. But here, instead of using the definition again, we're going to look at a more simpler form, easier to understand form to perform matrix multiplication. So first, we know that our final result is going to be a 2 by 3 matrix, right? So let's go ahead and open up something like that. I'm gonna make this matrix a bit longer because I need to write in a lot of numbers. Okay, so here we go. What we're going to do is we're going to take the first column, right, the 0, 1, and stack it on top of the first matrix like this. So 0, 1, like that, right? Okay. All right, and what you're going to do is you're going to multiply the corresponding column in here, right? So when you multiply by the first row, 1, 1, with the 0, 1 here, you multiply the 0 and 1 and add with the 1, 1. So for our first entry, since this is row 1, column 1, that is going to be our entry in row 1, column 1, the result. So I'm going to have first 0 times 1, so 0 times 1 plus 1 times 1. Okay, and that is going to be our first entry. Now we can take the same thing, the 0, 1 here, multiply by the second row, and that will give us the second row and column 1 entry, which is second row, column 1, which is this entry right here, 2, 1. And then you do the same thing, 0 times negative 1. So 0 times negative 1 plus 1 times 1. Okay, and that you will get your first column of entries by doing so. All right, now let's move on to the second entry. And let me erase this. Okay, I need a little more space. All right, so we're done with column 1 in the second matrix, so I'm going to erase that. Okay, okay. All right, and let's move on to the second column. So we're not going to use the first column anymore. We're done with that. All right, so let's move on to the second column, negative 2, 0. And then again, you take this and you stack it on top of the first matrix, and you'll get negative 2, 0. And we're going to repeat the same process again. So row 1, column 2, that'll give you negative 2 times 1 plus 0 times 1. And that will be here, negative 2 times 1 plus 0 times 1. All right, and then that is the first column, first row, second column. All right, first row, second column. This is your entry. And then we can move on to the second row and second column. That'll give us this entry right here. So do the same thing, negative 2 times negative 1 plus 0 times 1. Okay, all right, and then that gives us our second column in our final product. Okay? And then we can move on to the last one. All right, last column. 2, 3, and again stack it on top of here. So you're doing kind of like a counterclockwise 90-degree rotation when you stack it on top of here. All right, 90-degree. All right, take that, rotate 90-degree, you get horizontal 2, 3, and put it on top here. And then do the same thing, multiply by the first row. So you have 2 times 1 plus 3 times 1. Right, and then that gives you row 1, column 3, which is right here in green. All right, and then now row 2, column 3, you do the same thing, 2 times -1 plus 3 times 1. Okay, there we go. And that pretty much concludes what a matrix multiplication is. And then you just need to calculate the corresponding entry, right? So that's 0 plus 1, 0 plus 1, -2 plus 0. That's 2 plus 0, 2 plus 3, -2 plus 3, which is a 1. A 1 right here. Okay. All right. So basically, this works for any dimensions of matrix as long as the dimension matches, right? Again, by dimension, I mean the number of columns in the first matrix and the number of rows in the second matrix. If these two numbers are the same, then you can proceed with matrix multiplication, which is done in this form. Thank you. I'll see you soon.